Welcome back to part 2 of Unit 1, Day 2 notes. So in the previous video, we learned how to use function notation and how to operate with input and output values to solve our function. Now I want to do a similar process, however, I'll be using a graph instead of an equation. So remember when we replaced our x, we called that an input value. And when we had f of x equals, that would give us our output value. So f of x equals y. And I'm saying that to show you that f of x is the same thing as a y value. And my input value is my x value. So in this first problem, we have f of -4, where -4 is an x value. So we'll go to -4 on the x-axis and then find our y value from the graph. Our y value here is +1. We're going to do the same thing with the next problem, f of 0. 0 is within the parentheses, meaning it's an x value. So I'll go to 0 on my x-axis and go up to my graph to find my y value. I have to go up to 5 in this case. My next problem has f of blank, which means it's not giving me an x value, but it says f of blank equals 6, meaning that this 6 value is my y value. So I will go to 6 on my y-axis, which is my vertical axis, and then find my graph. I have to go over 3 spaces to get to my graph. So my x value will be 3. The next problem is similar. I have f of blank equals -7. So I do not have an x value, but I do have my y value. So I'll go to -7 on the y-axis and then go over to my graph. And that gives me -10. And my last problem, I have f of 5. We now have an x value again. So I will go to 5 on my x-axis and then up to my graph to find my y value. My y value here is 1. Now we're going to do the same thing with our second graph. However, the only difference is on this graph I have 2 different functions. I have a f function and a g function. My f function is outlined in the purple and my g function is in black. So my first problem says f of -4. Since -4 is within the parentheses, it is going to be an x value. So I'll go to -4 on my x-axis and look for my purple graph. I hit it on the x-axis, meaning I did not have to move up or down, so my y value is 0. My next problem is g of 0. 0 is inside my parentheses, meaning that it's going to be an x value. I go to 0 on my x-axis, and then I have to look for my g graph, which is black. I go up to my g graph, and that will give me 1. What does it mean when f of x equals g of x? That means it wants to know where f of x has the same y value as g of x. Then this is where my 2 functions cross. Where 2 things cross is called the point of intersection. So now it wants me to find f of 2 plus g of 2. So to find f of 2, I need to go to 2 on my x-axis and then to my f graph, which is pink. That will give me -3. And I need to add g of 2. 2 again is an x value, so I go to 2 on my x-axis, then up to my g graph, which is in black. And that gives me +3. When I add these two together, it gives me 0. Next, it wants me to find f of -7. -7 is an x value, and I'll go over to -7 on the x-axis and then up to my f graph, which is at 5. And then I'm going to subtract g of 2. Since 2 is in parentheses, it's an x value. I go to 2 on my x-axis and then up to my g graph, which is 3. 5 minus 3 is 2. And those are your answers. So here we're going to define a few more things for you. A relation is a relationship between a set of values. A function is still a relationship where each input has a single output. And that's the big key word here is single. And then here's a little refresher on domain. From earlier, I said domain is the set of all x values known as the input, and range is the set of all y values known as the output. Now I need to go and determine if these following functions are, these following graphs are functions or not. To verify this from a graph, we use something called the vertical line test. That means that if I draw a vertical line at any given point on my graph, it's only going to hit at one place. You see, I drew a few lines on this first graph, and it only hit at one place each time. Since they all pass the vertical line test, this one will be a function. So on to the second one, the one to the right of this first problem. I'm going to try the vertical line test. When I draw my first line, it only hits once, but my second line hits twice. If I draw another line, I can make it hit 3 times. So immediately after it hits my vertical line more than once, we know that it's not a function. All right, on to the next. The first line that I draw only hits in one place, but the second line hits in 2. Since it hits at 2 places, it's also not a function. The next problem, the first line that I draw hits in 2 places. So this one is not a function. And last but not least, at every place that I draw a line, it only hits one time. Since it only hits one time at each place, this one will be a function. Now we need to determine if these are functions using an input and output table. So remember earlier I said it is a function if each input only has one output. So with these tables, each input should only have one line drawn from it. So far on this first one, we're good because 1 only has one output. 2 only has one output. 3 only has one output, but 4 goes to two numbers. And 4 has two numbers or two outputs, meaning that this is not a function. Moving on to the next one. 1 has only one output, 2 has only one output, 3 has one output, and 4 has one output. Since each input only has one output, that means that this is a function. The next one, 1 has 1, 2 has 1, 3 has 1, and 4 has 1. So this one will be a function as well. And the last one, 1 has one output, but 2 goes to two different outputs. So immediately we know that this is not a function. Next, we're given a set of points and we need to determine if it is a function. So what I want to do first is look at all of my x values. I have a 3, a 4, a 5, a 3, and a -2. The first thing that I notice here is that I have two x values. Now I need to check those x values that are matching to see what their y values are. My first 3 goes with a 4, and my second 3 goes with a 2. Since these two x values are going to two different y values, that means that this is not a function. And last but not least, we're going to complete the following given the set of ordered pairs. So I'm going to first graph these points before I do the table. I'm going to do that so it's easier for me to put my points in order. So my first point is going to be -2, 2. My second point, 0, 2. My third point, 2, -6. My fourth point, -1, 0. My fifth point, 1, -4. And my sixth point, 3, -8. Now I'm going to look at my points from left to right and put them in the table. My first point is -2, 3. Oh, sorry, -2, 2. -1, 0. 0, 2. 1, -4. 2, -6. And 3, -8. Is this a function? I can check this in one of two ways. I can use my table to make sure no x values are repeated, and in this case they are not. I have -2, -1, 0, 1, 2, and 3. I can also look at my graph and try the vertical line test, which it passes, so this is a function. Now it wants to know my domain. Remember that your domain is the set of all your x values. When I have a graph like this where my points are not connected, or I have a set of points, I write my domain in this way. I open it up with a squiggly bracket, and I write my x values from least to greatest. And I close it with a squiggly bracket. And then I have to find my range. My range is all of my y values. And I will write that again from least to greatest using my squiggly brackets. My least y value is negative 8. It goes to negative 6, negative 4, 0, and 2. And my last piece, it wants me to evaluate f of 2. And I'm still using these points from above. Remember that 2 is going to be an x value. So I go look at where 2 is an x value, and it gives me a y value of negative 6. Next, I'm going to look at f of 3. 3 is an x value, so I will look where my x value is 3, and it gives me negative 8. And last but not least, f of x equals 0. In this case, 0 is a y value because it says f of x equals. So I will look for my y value of 0 and then find my x value, which is negative 1. And that's all for day 2 notes, or day 1 notes of Unit 2.